You've probably seen it, right? Those pictures of waves that glow this incredible electric blue as they crash ashore. Or maybe you've watched those documentaries, the ones that go way down into the deep, dark ocean, and you see these wild creatures making their own light. It looks like something out of a sci-fi movie, but it's totally real. It's called bioluminescence, and it is, without a doubt, nature's ultimate light show.
So that beautiful, almost magical glow. It brings up a huge question, doesn't it? I mean, how can a living thing create its own light? Where does it come from? Well, that's exactly the mystery we're going to crack in this explainer. Let's get into it.
All right, so first things first. Before we can get into how it works, we've got to understand what we're even talking about. What is this living light?
Okay, so here's the big reveal. It's not magic, it's chemistry, plain and simple. Bioluminescence is just what happens when a living creature creates and gives off light because of a chemical reaction happening right inside it. It's that straightforward. You could say it's just a special kind of chemoluminescence, one that life figured out how to do all on its own.
Now you might be thinking of fireflies, right? The classic example. But honestly, on land, bioluminescence is pretty rare. The place where it's absolutely everywhere? The ocean. Especially the deep sea. And when you think about it, that makes total sense. Down there, where sunlight can't reach, it's pitch black. So being your own flashlight, that's not just cool, it's a huge survival advantage.
So, if it's a chemical reaction, there has to be a recipe, right? So what's in the secret sauce? How do these critters actually pull it off? Let's get into the chemistry of this cold light.
So what's with the 0%? Well, that number tells you something amazing. Think about an old-school light bulb. You touch it, it's hot, right? That's because it wastes a ton of energy as heat. Bioluminescence, it's the complete opposite. It produces what we call cold light. Almost zero energy is wasted as heat. It is incredibly efficient. It's all light, no heat.
All right, to get this cold light, you really only need two main things. Let's stick with a car analogy because it's perfect. First, you need luciferin. That's your fuel. It's the molecule that's actually packed with the potential for light. Then you need luciferase. That's your engine. It's an enzyme, and its job is to get the whole reaction started, to turn the key, so to speak.
So here's the basic formula. It's actually pretty simple. You take your fuel, the luciferin, and you add oxygen. Then the engine, the luciferase, jumps in and acts like a catalyst, which just means it makes the reaction happen, and happen fast. The end result? You get a new molecule called oxyluciferin and light. The extra energy from the reaction has to go somewhere, and it's released as a photon. So yeah, fuel plus oxygen, with a little help from the engine, equals light.
Okay, but here's the thing. Life doesn't evolve these amazing chemical tricks just for show. It's not about looking pretty. This glow has a purpose. In the tough world of survival, especially in the dark, being able to make your own light is basically a superpower.
And this superpower gets used in all kinds of ways, but it really boils down to four main jobs. First, defense. The Atolla jellyfish basically sets off a burglar alarm of light to scare off predators. Then there's offense. You know, the classic anglerfish dangling that glowing lure to trick its next meal into coming closer. Then there's communication, like fireflies flashing messages to each other to find a partner. And maybe the weirdest one of all? Camouflage. Yep, some fish, like the hatchetfish, use light to hide.
This whole camouflage thing is maybe the coolest trick in the book. It's called counter-illumination. Just picture it. You're a predator swimming deep in the ocean, and you look up. You'd expect to see the dark shape of a fish against the faint light from the surface, right? But the hatchetfish has this figured out. It lights up its own belly to perfectly match the brightness of the water above it. So, from below, it's just gone. It's a literal, real-life invisibility cloak. So clever.
And it gets even crazier. Some deep-sea shrimp have developed the ultimate escape plan. Imagine you're a predator about to chomp down on one of these little guys, and suddenly, poof, it spews out a cloud of glowing goo. It's a smoke screen made of light. By the time you figure out what's going on, the shrimp is long gone. How cool is that?
All right, so we've covered the what, the how, and the why. Now for the really fun part. Let's meet some of the members of the glowing kingdom. It's a surprisingly diverse group.
What's amazing is that this ability didn't just evolve once. It popped up again and again, all over the tree of life. You've got glowing insects, fish, jellyfish, squid, you name it. But then you also get it in places you'd never expect, like mushrooms and even tiny microscopic critters.
Let's start with the familiar one, the firefly. Their flashing isn't just random blinking, it's a language.
Each species has its own distinct pattern, its own code, all to find the perfect mate in the dark.
Okay, now let's go from the backyard to the bottom of the ocean. The anglerfish. That little light it dangles isn't a friendly hello, it's a deadly trap. In the total blackness of the deep sea, that little glow is just too tempting for smaller fish, and it leads them straight to their doom.
And back on land, there's a really weird one. If you're ever in a forest at night and you see a strange, ghostly glow coming from some old, decaying wood, you're not seeing things. That's called foxfire. It's actually fungi doing its thing and lighting up as it breaks down the log.
And that brings us full circle, right back to those glowing waves we talked about at the beginning. What's causing that? Billions and billions of microscopic plankton called dinoflagellates. Anytime the water is disturbed by a wave, a boat, anything, they all light up at once. It's a massive, beautiful chain reaction. So, when you put it all together, you see that bioluminescence is way more than just a pretty light show. It's a masterclass in evolution. It's life itself using simple chemistry to solve the biggest problems out there. How to find food, how to avoid becoming food, and how to find a mate. All in a world where you can't see a thing. And that's what's so incredible, isn't it? In the absolute darkest corners of our world, life didn't just give up. It got creative. It made its own light. And it kind of makes you wonder, if that's what's going on down there, what other amazing secrets is the deep ocean still hiding from us?